Okay, in this video we're going to be looking at symmetry, so in particular line symmetry and rotational symmetry. So we'll just get you to write down the definitions and I'll give you a quick sample of what that might look like. So an axis or line of symmetry divides a shape into two equal parts. It acts as a mirror line, and it's often how we refer to it. So we refer to a mirror line with each half of the shape being a reflection of the other. The order of line symmetry is the number of axes of symmetry. So in this case here, we've drawn this example over here. We have the mirror line that goes through the middle. Both sides sort of represent a reflection of each other. It has that line of symmetry, or the order of line of symmetry is 1. Now the other one that we're going to be looking at here is order of rotation, and this is the number of times a shape makes an exact copy of itself after rotating 360 degrees. Now we say there is no rotational symmetry if the order of rotational symmetry is equal to 1. So if it only does it once when it goes all the way around 360 degrees, then it has no rotational symmetry. So let's have a quick look and we'll do an example of that to see what that looks like. So here we just want to do a quick demonstration to show you how we can find line symmetry and also rotational symmetry. So what we have is a rectangle here. Now the best way to find the simple one is regards to line symmetry is basically different ways that we could fold it so it fits on and it mirrors itself. So here with this rectangle, we know that if we fold it that way, it mirrors itself. If we fold it horizontally, it also mirrors itself and sort of covers that in there. Now one thing that we can get tricked at in regards to rectangles, if we rotate, try and fold on the diagonal, you'll notice that, you'll notice that it doesn't actually fold onto itself. So the easy way to do it is just to either fold a piece of paper so you can work out that line of symmetry, but also want to show you how we can work out rotational symmetry using these different shapes. So best way to do that is if I just draw a outline here, okay, of this rectangle. This will give me a sort of a set place or a set fixture to see how many times I can rotate this shape so it fits into that rectangle there. So we always start off in the beginning. So if I rotate it once, okay, it doesn't fit into that one there. If I rotate it twice, okay, so now you'll see that it's gone 180 degrees. So if I put that point there, that means that is its start. So as you can see again, so it starts at the top. I rotate it around, it doesn't fit until it's gone rotated 180 degrees, and because that fits in to that space there, you'll see that that is one rotational symmetry. I can then roll it around, it doesn't fit in until it goes to the top again, which makes it twice for the rotational symmetry. So that's one way that you can look at the rotational symmetry. Let's have a look now possibly at a square. So if I get rid of this and I show you what a square would look like, to see what the rotational symmetry would look like. Again, if I'll draw the outline, so I got my sort of starting space, and I'll draw a line here at the top. Okay, what we want to do, see if this, how many times this square will fit back into that pattern there. So starting with 1, rotates around for 2, rotates around for 3, rotates around for 4. So we know that a square will have 4 rotational symmetry points there. And again, similar thing, you'll use that piece of paper to see if you can do the lines of symmetry where it folds on itself horizontally, vertically. We'll try diagonally, which it does, so you can get that idea from there. So now that we've looked at that example, let's look at doing some of these practice questions. So you want to give the order of line symmetry and of rotational symmetry for each of these shapes. So we have here a rectangle, okay, which will be A. So we want to give the line symmetry and also the rotational symmetry order. So firstly we want to work out what the line symmetry is, and we know in a rectangle if we can draw a mirror line that goes sort of across the middle horizontally, that is 1, but also we can do it down vertically as it goes through that way as well. So we have those mirror images of each other. So our line order is 2 in this example. Now for rotational one, we know that if we turn it 180 degrees, okay, that will make 1, and if we rotate it 360 degrees, it'll also fit into itself. So our rotational symmetry is also 2. Now let's move on here to the rectangular pentagon, which we'll label here for B. Now what we have in regards to line of symmetry, basically in the instance here, any vertices that go straight across to the other middle of another segment, you'll notice creates a line of symmetry. So all these vertices that go across, we can pretty much fill this in from here. As long as we have something on all the vertices, we can know that our line symmetry for Pentagon will be 5, and for the rotational symmetry, it's also similar. So if we have 360 degrees, we can divide that by 5, and we know that if we rotate this around 5 times, each time it moves around, it will also go into fit into that same copy. So the rotational symmetry is also 5. So that's the information that you need to know in regards to symmetry. Make sure you have those examples down. We'll practice as we go through. Thanks, guys.